This tutorial is about the freezing process of meat. So we'll start with the definition of the problem, basically the boundary conditions and the geometry, and then we will implement that geometry and boundary conditions in COMSOL. We will add the materials that we need for this numerical simulation in COMSOL, because we will work, for example, with meat, which is not a built-in material in COMSOL. Then we will do the mesh for the geometry. We will set some parameters of the solver because the problem is stiff, and then we will run the simulation and analyze the data obtained from the numerical simulation. Our domain is a rectangular prism piece of beef of 54 by 32 by 10 centimeters in a cardboard box of 4 millimeters of thickness. The box with the meat is initially at 6 Celsius and then it is put in a chamber at -40 Celsius. The goal of the process is to reach at least -20 Celsius inside of the product, or inside all over the meat, and we will check how much time do we need for that using numerical simulation. Well, that's a representation of our geometry. The dimensions of the geometry are the dimensions of the piece of beef plus the box. So for example, the length of our piece of beef is 54 centimeters and the thickness of the box is 4 millimeters. So we have one layer of 4 millimeters in the front of the geometry, and then in the opposite face 4 more millimeters of cardboard. Then the total length of our geometry is 54.8 centimeters, and it is the same logic for the other dimensions. Outside of the box we have air at -40 Celsius, and additionally I put a mark in the middle of the geometry where this point is the central point and will be very relevant in our study because it is always the point that has the higher temperature of the domain. According to the definition of the problem, from the environment, for example, to this phase we have convection, and for the other phase we have convection too. So the geometry is regular. It means that the problem is symmetric. We can do the same exercise from the face in front and the opposite face, and the face in the top and the face of the bottom. So we have basically 3 symmetry planes, and we can take advantage of that. For example, taking only 1/8 of the geometry. Imagine that we take this part of the box and then put it right at the side here. You can realize that the central point is here, so we are taking this 8 of the box, and if we set as boundary condition at the bottom and the left and in the front as symmetry, we will obtain the same result for this point than using the wall geometry. So we can take advantage of the symmetry working in a smaller domain which require less elements basically. Well, doing additional studies, this dimension is significantly bigger than this and this dimension, so we can neglect the heat transfer from this phase up to this point. We are looking at the temperature in the central point, as you can remember. So basically we can work with a 2D domain. The boundary condition for this 2D domain is here. I have a zoom here of the same piece. So this boundary corresponds to this boundary. So we have convection, and here is convection too because corresponds to this part of the box, and then here this red line is this line, and this line here is this other red line. So the boundary condition for this boundary and this boundary are symmetry. Here we can see a representation of the meat and the cardboard. With that geometry established, we can put now this geometry in COMSOL.